Hello mortals. This screen is made up of many atoms. And so are your eyes. And so is your brain. In fact, we are just a bunch of atoms that are trying to understand themselves. Here's a funny way to think about the history of these particles. In ancient Greece, some pre-Socratic clumps of atoms asked themselves, what will we see if we zoom really deep onto ourselves? Because of their lack of technology, they could only make philosophical guesses about it. And so, they came up with the idea that everything is made up of indivisible particles, called atoms. So that's the first instance that a bunch of atoms acknowledged their own existence. During the Middle Ages, atoms forgot about themselves because of the Church, and only in the 19th century the theory became mainstream. By now, you might think that everything around you is made up of atoms, but you'll soon see why this is not correct. Thanks to Manscaped for sponsoring this video. During the last 2 centuries, the so-thought indivisible atoms were discovered to be made up of protons and neutrons at the nucleus, and electrons orbiting them. And nope, that's not how an atom looks like. This is more like it. The electrons don't orbit them in the usual way of thinking along circular orbits. Instead, they exist inside these probability clouds. Because of weird quantum physics, we can't really pinpoint their location in one place, instead we can only approximate. They are most likely to be in the darker regions, and less likely to be outside of them. But aside from them, there are many more particles in physics that have been discovered. Luckily for us, scientists have arranged them into a table called the Standard Model. But if you take a look, there are no atoms, no protons and no neutrons. The reason is that the Standard Model only contains elementary particles, that is, particles that are not made up of anything else, or at least that's what we think at the moment. Atoms are composite particles, as previously shown. And so are protons and neutrons. They are actually a combination of 3 particles called quarks, which can be found in the Standard Model. Quarks come in 6 flavors: up, top, bottom, down, which are not the same. You can thank the very creative scientists as always. And there are also the charming and strange quarks. The up and down quarks make up almost all the atoms that you can see. With their charge of positive 2/3 and negative 1/3, they make up all the protons and the neutrons and are held together by gluons. The mediators of the strong nuclear force, basically flex tape. The rest of the quarks can only be observed in particle accelerators. With the exception of the strange ones. They could hypothetically clump up into bits of strange matter, and destroy and convert anything they touch. Here's our video about it. Fun fact, quarks never like to be alone. If you try to pull 2 of them apart with a lot of force, they will use that force to generate 2 more quarks. Next up are the leptons. First, the good old electron. It orbits the atoms, as you already know. It also makes a zzz sound when you put a fork in the socket. Electrons aren't made of anything smaller. However, at temperatures close to absolute zero, and extremely tightly confined, they divide in 3 quasi-particles: spinons, orbitons, and holons, as if they existed independently. Next, the muon, the big brother of the electron. It is 200 times heavier and leaves quite a long and boring life. You could replace orbiting electrons with muons to create, say, muonic hydrogen. Muons could also be of help in developing cold fusion, that is, thermonuclear reactions at room temperature. Next up are the tau particles. If muons were the big brothers of electrons, tauins are the ultra-mega big brothers. They leave for a lot less than the latter though, therefore they aren't really observed in the real world. We have 3 more particles left of the leptons, and they're all neutrinos. Each corresponding to the particle above. They are created from the decay of other particles. Because neutrinos are electrically neutral, they don't interact with the electromagnetic waves, and can pass through a lot of matter before hitting an atomic nucleus. That's why they require some very huge underground detectors. There are trillions of them passing through you right now, and they might be coming from billions of light years away, produced by very energetic processes. They're also the smallest elementary particles known to date. Alright, so we're done with the fermions now. Oh god, what the heck is this? Oh right. Every fermion has an antiparticle counterpart. The only difference is that they have opposite electric charge. That way you can create an antihydrogen atom from a positron and an antiproton. Make a lot of them and you've made an antimatter bomb, the most devastating explosive possible. But making antiparticles is really expensive, $62 trillion per gram. And that's not including shipping costs. And what the hell, scientists, why isn't an antibottom quark the same as a top quark? Or this? Anticharm. Is this a quark name, or an insult towards me? Moving on. Bosons, particles that carry a force. And as we know, there are 4 fundamental forces in the universe. Air, water, no, gravity, electromagnetism, the weak and the strong nuclear force. As previously mentioned, the gluon acts as glue between quarks, and as a carrier for the strong force. Photons are the carriers of the electromagnetic force, and are the reason you can see this video right now. Apologies to my blind viewers. The Z and W bosons are carriers of the weak nuclear force, responsible for the decay of particles. So what about gravity? Sadly, we don't know. We hypothesized that there should be a particle called the graviton, which mediates the gravitational force. But until now, scientists haven't been able to integrate it into the standard model. Thank quantum physics for that. But what's up with this yellow fellow? You probably heard the name, the Higgs boson. It was discovered a few years ago. It is the reason particles have mass. Think of the Higgs field as an ocean, and everything passes it has to push through the water to move. Some may have to push harder, that's why different particles have different masses. Fun fact, Olympic swimmers shave most of their body hair to glide faster in water. And oh man, do I have a great offer for you. We have partnered with Manscaped to bring you the world's first all-in-one grooming kit that makes below-the-waist trimming safe and easy. With the Perfect Package 3 kit, you are getting a ton of value. First of all, the Lawnmower 3 waterproof trimmer, with soft ceramic blades, and a skin-safe technology. It is cordless, has an illuminating LED light, and it comes with a USB charging dock. Inside the Perfect Package you are also getting a deodorant for your basketballs, and a refreshing baseball toner. You are also getting a limited-time anti-chafing boxer briefs. All of that comes in the Shed travel bag, which is a free gift. Also, every 3 months, you are getting a replacement blade refill for your lawnmower trimmer, delivered right to your door. Get 20% off and free international shipping, plus the 2 free gifts when you use promo code SCIENCE20 at manscaped.com. Link in the description.